Well, we're finally meeting in person, and I have been looking forward to this for 20 months now. And thank you so much for inviting me into the headquarters of your new endeavor. This may be the first guest that needs absolutely no introduction, with the highlight career, the career that feels like a highlight reel between Intel and AMD and Apple, churning out success after success. I still need to let our audience know I am being joined by Raja Koduri. Thanks a lot for inviting me in.
Thanks, Justin.
Absolutely. And you know, I mentioned that 3-decade career of successes. I'm curious, what still fuels your curiosity?
It's interesting you ask. Actually, it doesn't, feel like I'm slowing down. It's like I'm on a new gear, the past couple of years than before. When I started my career, especially on the semiconductor side, somebody showed me this, transistor IV characteristic curves. So you have voltage on the x-axis and current on the y-axis. And as you increase voltage, the current increases up to a certain point, and then it flattens, right? You can increase voltage, but it doesn't, right? This person told me that people's careers are like this, different, the transistors have different characteristics. Some extend all the way to the right. He said, some people plateau. This is the plateau you reach. No matter more voltage you get, you don't get more current. He said, some people plateau in their 20s, some people plateau in their 30s, some in 40s, some in 50s. Right? So I feel like, my plateau, I haven't reached my, plateau yet. It may be 60s or maybe 70s, right? Wow. And the stuff. So, that stayed with me, right? It's basically, and that's the young advice I give to a lot of young people is you get to choose, and that comes with learning and curiosity, as you mentioned, right? So if you're continuing to learn and want to solve new problems and go after, you're not plateauing.
Absolutely.
Right,
and I mentioned you don't need an introduction, but it is my pleasure, my distinct pleasure, to be able to, for the first time on camera, introduce you as Raja Koduri, CEO of Oxmiq. Before we get to that, though, I had an inkling that something was happening for a while. Can you tell us a little bit about the journey from Mihira to Oxmiq?
Yeah. So, I left Intel, little over 2 years ago, right? Maybe 2.5-ish now. And I started Mihira with a few goals in mind, okay? Few external goals as a product and as a platform. And they were internal goals too. The external goal was we wanted to build a heterogeneous computing platform for content creators. Right, like the people who do movies, games, etc. And why heterogeneous? Because we wanted to keep the capex and opex very low. Because if you recall, in the 23 time frame, it was impossible to get an Nvidia GPU, and even if you could get it, it was 2 to 3 zeros more than you could afford.
Yeah.
Right. So. And we also picked India as our initial target market, primarily not only because the access we have there, but also because it's a very cost-constrained market. So it forces us to solve hard problems, right, to come up with this stuff. So we made quite a bit of progress, but we also built a studio inside the company as our first user. So it's kind of like our own internal beta tester for all these new tools and new stuff. So that was the, kind of the external product thing. There was an internal motivation. My career over the last, I'd say, couple of decades went closer and closer, kind of down the stack. I was spending a lot more time closer to the atoms, as I say, right? Closer to the transistors, hardware, and all. And I felt like I lost touch with the top of the software stack, right? What was happening, this whole Python, PyTorch ecosystem, AI, the kids programming in AI, right? I grew up programming in C++ and computer graphics, APIs and all. So the internal motivation was I wanted to get hands-on learning of the software stack, what's happening at the top of the software stack, which we now in the 2 years, the top of the software stack is what we call agents, right? So that's, and that was very, very important part of the learning of Mihira, which kind of led to Oxmiq and other things. So in the studio, we spun it off, and they became successful. They have big projects that they're working on. So we said that's great business. Let them run, and I collaborated with Shobhu Yarlagadda, who's a big time, very successful content producer in India, behind films like Bahubali, which is one of the largest blockbusters out of India. And my first cousin, S.S. Rajamouli, he's the most successful film director out of India. Wow. So they are taking care of it, and the technical vision, the technical foundation of Mihira is our contribution, and we continue to collaborate with them, and we help them with things like agents and AI needs.
What a neat story, and to bring things full circle. You didn't know this, but you actually proved me right within our internal team, because I got a lot of pushback on including Mihira in our top list recently of companies to bet on, and the reason was, and what I told them was, it can't just be software that Raja is working on. And so I knew something was brewing, and this is what it is. And I'm curious, a name like Oxmiq, I looked it up in the dictionary and it's not there.
It's not there.
You got to tell us, how did the name come about?
Yeah, so within the first 6 months of the Mihira journey, and we started understanding, the software challenges, right, of deploying on heterogeneous GPUs and all. I incubated a small team called OpenXPU. So we incubated a company called OpenXPU. So OX, it comes from OpenXPU, and OpenXPU was, I think, half a dozen world-class architects who are now all part of Oxmiq, and they started working on a new IP, GPU IP, and the software stack, right? And sometime last year, when we came to a point where we said, okay, let's spin off the Mihira studio, we wanted to combine the OpenXPU and Mihira into one company. And Mihira built the Python software stack, what we call Capsule, right, was part of the Mihira engineering team. And OpenXPU built OxCore, OxQuilt, those technologies. So, as with many naming stuff, you come to a date, you had to make a decision before the next investor coming in, and paperwork and re-registration. And one night I said, okay, I'll pick Ox from OpenXPU, MI from Mihira, right? Ox MI, that felt incomplete. We wanted, something, a fifth letter to kind of finish it. And we picked Q, because first Oxmiq, I could get the domain names. That's one thing, practical issue. But Q, this is a deep nerdy stuff, right? Our architecture is a completely Q model based stuff. So Qs are everywhere, if you open up our documentation. But the second thing is, Q is for quiet. We want it to be quiet, right? Q. So anyway, Oxmiq came about. So it's not a, some fancy inspiration. It's not a Greek goddess or Greek god for something. So it was a practical thing to bring our two teams together.
Well, that's one of the neatest naming stories that I've ever heard. And there's absolutely no shortage of compute companies out there. And what you guys are building, though, really just feels distinct, both in architecture and definitely in ambition. What's the core problem you're trying to solve, and why is now the right time?
Yeah. The core problem in as simple a word as a way I can say, is we want to enable you to build your own compute. Okay. What I mean by that is, if you see the promise of AI, right, it is going to touch everybody's lives in unimaginable ways than, this stuff. So, but today's AI, right? If you take I'll give you one dimension of today's AI. Deploying 1 million agents, whether they're coding agents or stuff that everybody is super excited about and talking about, costs you just a capex bill of AI hardware of $28 billion for 1 million agents. Okay, now everyone talks about, right? It'll be a trillion agent economy. Okay, forget trillion. Before we go to trillion, if you look at a billion, a human scale is 8.5 billion people, right? So if you want to get to human scale, okay, the capex you need is twice the global GDP. Okay, it's like $237 trillion. Okay, and the energy you need is 3 times the global energy production to do AI the current way to scale up. Okay, but we have faced these type of junctures before. To solve it, there is a lot more innovation in computing that is ahead of us, not behind us. So what we know as a GPU today, what we know as the big systems that Nvidia is shipping and all, they're great for today. But what they will be 5 years from now, what they need to be 5 years from now, will be dramatically different. But they will only be dramatically different if we enable a larger pool of innovators to be able to build chips, systems, silicon, right? If it is just concentrated on 1 or 2 companies, it won't happen. I mean, we saw this with software, right? Yeah. I mean, it's like if it was concentrated at Microsoft and Linux didn't happen, open source didn't happen, Python didn't happen, we won't be in this world, right? So the similar movement on hardware is happening right in front of our eyes. Amazing progress in open source hardware. RISC-V generated that momentum. There are small teams aspiring to build chips, chiplets, and all. So what the problem, coming back to your question, right? We said, what are some of the missing ingredients for you to make your own meal, right? And the stuff, right? So you want to cook your own meal. There is a customization. If all of us got same cookie cutter meal, right, that you order, and its expense is going up and up and up and up and up, and what is the key ingredient missing? What is that is not available to you for you to get? You can do the rest, right? You can have your sauces, you can have your salt, you can have your stuff. What are the key ingredients that are not in the supermarket right now for you to buy? And that one of them is this thing, the GPU IP, what we call OxCore.
Yeah.
And OxQuilt doesn't exist. There is no such thing you can go buy from a market today for you to build your own GPU system, right? So that and then the IP is connected to software, and so you just can't do hardware IP. You also have to do the connected software IP for you to finish your meal, right, and this stuff. So that's that's the problem we set out to solve.
Wow. Well, and to expand on what you were just talking about on the software side, you said something really interesting, that software isn't really that software problem is really an architecture problem, which is completely flipping the script on what the narrative seems to be out there today. Yeah. And I love that, and that seems to be really corollary with how you built your career. It's rebel thinking. Yeah. Tell us what you meant by that.
Yeah. So there are very few people, in the industry today that really understand what a GPU architecture is, right? And really, from first principles, understand why Nvidia is so successful. Okay. There is a lot of mainstream narrative on either CUDA or Jensen is a great guy, no question about that. And there's a lot of stuff. But what they have done is a hardware, software, co-architecture and innovation. So CUDA in isolation wouldn't be successful on somebody else's architecture. CUDA is successful on Nvidia hardware architecture, right? So in parallel computing world, right, it's basically how I express my work, right? If I'm asking you to do work, right, actually, let's say they are not just one Justin, they are a million Justins, right, and the stuff, and they are ready to do a lot of work for me, okay? The way I describe work, which is the programming model, right, and the way you consume work and get it done has to have some correlation. So you cannot just do software. I can't just sit and say, oh, the way I describe work is like, what is really good for me, I'll do it in English and or like, California English or like, or some other language and this stuff. And there'll be a translator and like, Justin will figure it out, right? Yeah, you can do that. But Justin efficiency will be low, right? Instead of utilizing all million Justins, I'll be utilizing only 50% of them or 30% of them. So you have to architect, Justin and Raja together.
Yes.
Okay, in this workflow of analogy. So that is what I meant by it is software problem that everybody talks about. Oh, Nvidia is ahead on software and everybody is behind. No, Nvidia is ahead on architecture, hardware architecture, and they have a software coupled with that architecture.
That works perfectly with
it. And the stuff, right? So that is, that's why they're a $4 trillion company today.
Well, and it's interesting because somebody who both of us respect a lot, you spoke to recently, Sally, and you mentioned to her, you called CUDA a virus that has spread. Tell us more about that.
Yeah, so CUDA in its original instantiation, and still is, right, is the underlying kind of, I'd say, the lowest level abstraction by which I can describe work to you, right? Like I said, I want to tell you what to do, right? And, I can express that in this language called CUDA, right? But there is an entire layers and layers. It's not me telling you work. I have another, my boss also, passing work to you, right? The stuff, through me. So he expresses in a different language, but his language is also, I'd say, constrained by what I can understand, which is CUDA, right? And the stuff. And then what you understand is also CUDA. So this assumptions around CUDA and Nvidia hardware appear in layers of the software stack much above the real CUDA layer, right? Like so if you look at Python, PyTorch, PyTorch has an entire module called torch.CUDA. Okay, it's not actually CUDA code, it is Torch code, but there are a whole bunch of assumptions around Nvidia GPUs that are permeated up and up. And much of it, the developer doesn't even know.
Yeah.
Right? They are creating, they're doing this stuff that it is, strictly tied to Nvidia. So that's the, I say the CUDA virus has spread, throughout the stack. And, that's the basis of my statement.
You also mentioned that part of Oxmiq stack could actually even benefit Nvidia.
Yes.
And that some elements of your stack will be open source. Why focus on ecosystem enablement and collaboration rather than building your own software moat?
Yeah, no, great question. So, it actually goes back to what is the opportunity ahead of us, right? So if we are trying to create an entity that is, let's say, right, short-term focused, make some, revenues, profitability, drive up our valuation and maybe, successful M&A and exit or something like that. Okay, that is one path. Nothing wrong with that, quite successful path. What motivated us, the group of people that got together, is we wanted to create a new architecture, right, that or inspire a new architecture. And, our ego is not that high to say that what we started, what we are germinating, will just be our contribution. There'll be other ideas that will come into this stuff. So when we open up, you're getting the brain power of a lot of people to kind of build the next 20 years. So like I said, the TAM is $237 trillion right now. Okay, so So even if we modestly get 0.1% of it, 0.01% of whatever is in 2028, 29, we are still a very successful company. So you can actually be sharing and also be extremely successful just because it is a huge growth market. So if you are on a flat market, and I'm just trying to, it's a zero-sum game,
Yeah.
and I'm just trying to take from you, right? Then all the techniques, I stay closed, I stay this, that matter. But when it is such a rising tide and it's like incredible, right? Nvidia revenues have been doubling every year.
Yeah.
And they are supply constrained, not demand constrained. Okay.
Right.
So it's a great time to be doing this. And we said, why are we, short-sighted? Don't be short-sighted on this, right? Go participate in the bigger thing and enable this stuff to happen.
And if we're staying on the commercial side of things for a moment, I'm sure many will be curious about why you chose a licensing first model instead of building a chip startup with a focus on the tape outs. Can you tell us a little bit about that?
Yeah. If you look at how many design teams exist across the world that are capable of assembling a chip and taping out, they are over 1,000. Okay, maybe more. Okay, all of them become our customers, right? If I do a chip, of course, we are silicon engineers here. We'd love to do chips, ourselves. Then I immediately, my IP becomes a competitor to my potential customer. Because then I have to pick a segment to do a chip in. Let's say I pick edge or I pick data center, right? Then my potential licensee would say, hey, you're doing a chip, and of course you're more familiar with your IP. Why would I win this particular stuff, right? So, we are inspired by the success, even though, it was a long journey for ARM, right?
Yeah.
Imagine without ARM, you wouldn't have the machine in front of you, right? You wouldn't have the phone, you wouldn't have the stuff, right? But ARM didn't build a chip.
Right.
Because we could license ARM IP, anybody, anywhere in the world could license ARM IP, the innovation in mobile happened, right? Imagine if the mobile world waited for Intel's x86 to hit sub 1 watt. It wouldn't have happened.
Yeah.
Right? I mean, that's exactly the analogy if you think of, right? And if you're waiting for physical AI and, 8.5 billion people to have access to AI, just like they have access to electricity or something, and you say Nvidia is going to do it, it's not a practical thing.
Yeah.
Right? It's not a statement on their capability or capacity. It is just physics. These ecosystems there'll be chips developed in places everywhere across the world. Every country, right, capable will have their own sovereign initiatives, right? Like, India has its sovereign initiative. Europe has sovereign initiatives, right? Singapore, Japan, right? Of course, China is far ahead of everybody on their sovereign initiatives. So they all need, we believe we can contribute with our knowledge to all those initiatives.
Well, and what I love is your RISC-V forward. I think there's going to be a resurgence within RISC-V that kind of plateaued for a while. And another space that I've been a big proponent of for years is the chiplet space. And in the future, you guys have something that you're referring to as OxQuilt that helps that domain. Can you tell us a little bit about that and your belief in chiplets as a future?
Yeah. I joke, and I said this to Sally, a few years ago, that a lot of people are excited about chiplets, and they say the people who talk a lot about chiplets are the ones who haven't done them. Right? And that's, not a negative thing. I have done, the chiplets, right? We are the first ones to do HBM at AMD, right? Chiplets at AMD. And then my, recent project at Intel, the Ponte Vecchio, the exascale one, had 47 chiplets on a single package, okay? So it's insane, the amount of scars on my back, right, that are still healing on the learnings from doing chiplets, right? So there is the romance of chiplets, what they could do, but then there are lots of practical learnings we had on, how to design with the chiplet concept, how to yield with the chiplet concept, how to test. So there is all your fundamental pipeline of development of all silicon companies is set around monolithic, right? That's what the last 30 years have been. So this chiplet-based development, and especially high bandwidth chiplets, it's another engineering discipline that is being developed right in front of our eyes. So with the OxQuilt concept, what we are bringing forth again is our own learnings or our own scars on the back, right? So that others don't need to repeat those, right? So we are packaging all those into a set of tools that our customers can leverage and much more efficiently decide what is the boundary. When you say chiplet, right? What makes a chiplet? What do you want to put in it, right? Say you're making a chiplet, I'm making a chiplet, he's making a chiplet, and all three needs to come together to build a system. What is in my chiplet could be computation. What's inside your chiplet could be memory related stuff. What's inside his chiplet could be interconnect related stuff. And what are the ratios of those that are needed for a given platform? For example, or for a given application. For an edge inference application running reasoning models, I may need more of your chiplet on memory because it's very, very memory bound, and a little of me and a little of interconnect.
Yeah.
Okay. So then you can get a very optimal cost efficient solution just spending silicon where it matters.
Yeah.
Whereas today when I buy one big GPU with fully loaded, I am underutilizing it, sometimes by like underutilizing 90% for my inference application. But that's the only thing I can buy that works with my software stack.
Yeah.
See, if somebody could say all this AI started, I have something more efficient and all, but my software doesn't work, I can't deploy. So the OxQuilt approach is you can assemble the right ratios between your compute need, memory need, and interconnect. And largely today's AI, it actually sounds very simple what I'm saying, but it is actually true. It is the ratio of these three things. That, with which you can go from a massive training cluster to a data center inference cluster to an edge cluster to what you put inside a robot to what you put in a phone. I can list you these ratios between flops, memory bandwidth, memory capacity, and interconnect bandwidth. That's really the main difference between all these instantiations from a silicon perspective, from a hardware perspective. Of course, software, how do you program this stuff? And that is like, with our Ox Python and Ox software stack, we are giving tools to have one common software infrastructure that you can, assemble together for all your needs.
That's fascinating. And while we're on the self-abuse topic where you're getting battle scars, you talked about some in the more distant past. If we're to fast forward and talk about a recent battle scar, one of the things that I've always appreciated about your leadership is your humility. Is there a point that you can point to in the learnings in the last couple of years of forming Oxmiq that really helped to shape the company into what it is today?
Great. I mean, it's an interesting question because, the learnings are like, that many times when you look back, right, right over 5 years or stuff, right, it takes time to assimilate the learning. So I'm still in a new learning loop, right? So it was hard. It was super hard to convert the theory that right, on what you want to go about to practice. So one thing about a startup, right, and for people listening to this that want to become an entrepreneur in a startup is as a CEO, right, is your first opportunity. It was my first opportunity to establish my own culture, right? The companies like, say, Intel, AMD, Apple, you walk into a culture. you can have influence, as leadership levels, you can have some influence on it, but you don't create it from scratch, right? So here you create it from scratch. And that is a very, very, very hard thing to do, right? No matter what the size of the team is, right? So it takes iterations, it takes, people getting angry at each other, right? The egos, we only have 20 plus people, but it feels sometimes like there are 250 people because these are big brains, right? So their capacity is 10x, even though the team is small. And with the capacity, the egos can also be 10x, right? So how you manage everybody's egos to be a cohesive team is a hard problem. Lots of lessons learned, and that itself, right? The ego management is probably a whole podcast in itself that we can talk, right? Because people have a negative connotation with the word ego. Actually, ego is not bad. Ego, the right amount of ego. It's exactly right amount of ego, because without ego, you don't create. What gives you the permission to say, oh, a small startup with 10 people is going to go build this great thing, right? So you have some ego, right, to say I can create it, right? Yeah. So it may be delusion sometimes, but but without that you don't start, right? And the stuff. So you need that right amount combined with the right balance of humility. And going back to the cooking thing that we talked about, right? These are all balance, right? Balance of ego, balance of humility, balance of hard work. Right? You got to have all these three ingredients to have a successful startup. So those are the learnings on that, hey, you just don't tell everybody once and say, hey, come in and this stuff. So you have to live it, you have to breathe it. I have to set a personal example, and everybody has to do that. And so we go through those struggles. It's not a rosy picture.
Let's flip over to a happier note. On the last couple of years, what was that one defining moment that you can point to where you felt most inspired, most convinced and convicted that you're on the right path?
I would say it is more recently, when all of the pieces we were working on, we were architecting, some of it was in PowerPoint, some of it was code being written. They all came together when I see the first actual code running from end to end. And we can start measuring our progress. That's when I said, okay, we are, I felt quite good. And in fact, that part of the reason, a big part of the reason why we chose to go public is because we hit that point very recently, right? And yeah, you could say, oh, it's a tough, long road for you to be in the uncertain mode and stuff, but that is, creating new things. You have that. We may externally appear confident to everybody, right, to investors or to anybody, because you need to
Yes.
to raise money and all, but really the proof is in execution. When you see the machine running, and as engineers, we need to see the machine running, and doing some stuff. So that's our inspiring moment, and that's why we all came together. That last night we had an open house, and you should see the energy here,
Yeah.
right? And it was amazing, right? Not just our employees, we have excellent pool of interns right now, right? It's just the interns just inspire me and also scare me. They are, some of them just hit 20 and they are smarter than the entire building. And I'm like, oh my God, what are these kids going to do, right? In future.
Well, you're obviously on the right track, because the small team that you have built, and I've been in helping architect companies now for almost 20 years, and I can't remember a time when a startup company was able to attract such a highly talent dense and experienced group, because in that small group you've got over 500 years of experience represented. If you had to boil it down to one or at the most two traits that you've looked for in every person you bring in the company? What are the attributes? What are the traits you look for?
Passion. The number one is that they have almost a unhealthy amount of passion for the problems we want to go after, right? Like, the second attribute is persistence. This is going to be hard. This is going to be, that they can persist on a problem long. So those are the two attributes I look at, right?
And how do you screen for that? How do you look for that? Because one of the things that we have found is that as important as attracting the right people and compelling them to get excited about your vision is repelling the wrong people, making sure you keep the wrong people out. So some people can fake certain elements. Is there a secret sauce you have in identifying that passion and persistence?
Oh, no, I mean, great question, by the way, right? We have learned, right? Like you said, a lot of people, can you say, fake or like delude themselves that they have the passion and persistence, and then we'll see that, like, that falls apart really quickly, right? And how do you screen for that? I think over years, you develop an intuition. Right? We develop an intuition. And then there are little things that, give it away. It's little things that you start observing even during the interview process that give it away. So, and my advice to, other founders and all is, if the intuition, if it doesn't feel right, even if all the, the checks work out, see if they are willing to do, 3-month advisory role with you, right? That are they interested enough that they would take a risk and say, okay, I would do. And the team that you saw, Oxmiq team, pretty much everyone went through that.
Wow.
Right? Some of them actually 6 months no pay stayed, said, we love the problem. And, we want to start working, and, we'll see if our culture matches, our cadence matches, we are, right fit for each other. So that commitment is another way to filter stuff out, right? Everyone can't afford that, right? And the stuff. So, this is not a practical advice for everybody, but we got fortunate that the key core team that is here sacrificed several months to see if it is the right fit.
That's impressive. It's very different building a team in an Intel, an Apple, an AMD than it is in a startup environment. What are some of the things that you've seen that differentiate building a team at a company like Oxmiq versus almost a resource unlimited environment like those big companies?
Yeah, I mean, it's basically black and white. It's just two different worlds, right? On the stuff, and it's that question is a very important question today than 5 years ago, 2 years ago, even 1 year. Why? Because the impact Gen AI is having also changes the answer to your question in a significant way, right? We are just in the middle of a major, you can call it disruption, upheaval, right, in the way we build stuff, in the way, the development happens, because these coding agents are amazing, right? So what they're doing, Justin, is, and this is like, the answer to your question, there is no cookie cutter answer for this, because as I sit here today, an experienced person with the passion and persistence that I talked to you about, that has some breadth on the subject matter and some depth, these coding agents are like you have equipped them with 10 engineers to work for them. So they are being 10x productive, maybe even 100x productive in some cases. So the attitude of big companies or any prior stuff that, oh, I need to do particular thing, I need a team of 10 people, I need a team of 100 people to get that. That equations are changing right in front of our eyes, and we are a living proof for that. Okay, so and that also changes the startup equation in a significant way. As you know, it's no secret, right? Like, you know, the startups were heavily weighed towards youth, right? You know, the founder and the team that will burn the midnight oil, that has the, you know, the health and capability on their side, right? You know, that will do insane amount of hours and all that stuff, and will do, you know, their failure iteration loops, you know, fast and all that stuff. But I think the coding agents shifted the balance, that the value of experience, the value of gray hair, the value of bald-headed people is 10x now, because, but they need to have the right fire still left. You know, a bald-headed or a gray-haired person that hasn't hit that plateau stuff is worth their weight in gold right now, because they. The agents do burn the midnight oil for them, even if they have to get their 8 hours of sleep, right, and the stuff. So you get that blend of their experience, which to build a complete working system and to specify, to ask the right questions, right, to frame the questions right, which comes from experience, right.
Do you think we're gonna, that will actually shift the trajectory and hiring trends too in the near-term future within our industry? That sometimes the elder statesmen in our industry that have had a harder time getting into companies might actually be boosted now?
I think so. I think the companies that realize this sooner than later will be very successful, right? And definitely.
Well, I'm definitely in that balding camp. I'm losing the hair, and you're grayer. And so as we lose hair and as our hair goes gray, we start thinking about life and work and everything differently. I'm not calling this shot, but this may be your magnum opus. How would you if you could paint a picture 5 to 10 years from now, what would you like for the legacy of Oxmiq to leave?
You know, honestly, I don't, think much about, the legacy stuff, and if the Oxmiq is the magnum opus, right? Like I said, I would like that the transistor characteristic curve go as far to the right as possible, right? And there's just a bit of a personal thing here, right? I was inspired early on into getting into computer graphics by one of my uncles, who's a painter, who's an amazing artist, who actually just about a month, month to date, passed away. He was 93 when he passed away. And even until 92, okay, he slowed down the past year. Until 92, whenever I go to visit him in India, he was creating. And he was doing stuff. He was had still a 10-year plan, right, at 90. And we used to laugh at that as, me and my cousins, in the stuff that, how's he going to do this? He can't, right, he's 92. And I think about that often, and I say, it's I'm inspired by that he kept creating. He did amazing amount of art, even into his 80s and his 90s and all. I say, hey, if I can be like him, right, in this stuff, then I've lived a good, full, productive life. And in the process, the legacy is really the young people we inspire, right? The young people we teach. And to your point earlier that we were discussing, right, I think youth now coming out of schools and colleges, the value of breadth, the value of understanding system, architecture, or, our whole education system started, I don't know, like 200, 300 years ago. And like, as you get into college and all, focused on hyper specialization, or you become like, this, right? Narrow branches of engineering to go and this stuff. But I think the breadth becomes far more important, because some of the narrow knowledge retrieval, which we are training people to be answer machines on a particular topic, the LLMs are your answer machines, right? The human ingenuity is, what is the right question to ask, right? So being able to inspire more people, and like our interns and more people through this journey, through the companies like Oxmiq, right? It gives me a great satisfaction that we got 10 interns going through the stuff and are being inspired. That is what I look forward to more so than a moment of legacy, or that we created a great new GPU architecture, or created a picture number of zeros valuation company and all that stuff, right? Those are great because you need money to feed these pursuits, right? But to me, that is where that ends, right? So that the pursuit of the zeros is not what inspires me and many members of our team too.
Well, I can say that there is a lot of coherence to what you shared, and your uncle probably shaped your thinking in ways you didn't imagine, because what you described as one of the traits you look for in people, and passion for what they're doing, and almost a willingness to do it for free, at least for a little bit of time, is indicative of how he lived his life, because he did the work for the work's sake, because he loved it. And you have also given so much to the GPU community because you love the work, and we're indebted to you for that, and can't wait to see. My hope is that a year from now, I'm back in this seat, and we've got an Ox Hardware
Yes.
poster behind.
Yeah.
But until then, again, thank you for the welcome to learn and be inspired.
Thank you for making the trip.
Absolutely.
Thank you.